Hello, this is Gavin. I'm making this video to showcase my libraries project. So first of all, let's look at the functions I created. So the first one is, well actually, let me start off with the theme. So the theme of this library is to help you solve gas laws problems in chemistry. So I have ideal gas law, I have the Charles gas law, Gay-Lussac combined, and that we'll talk about that later. But those are the four gas laws that I have, and that you can use. You can use these functions to solve problems with gas laws. So first of all, we have the ideal function. So this one takes five parameters, and that would be the pressure, the volume, the how many moles, the substance, the gas constant, and the temperature. So about these things. Pressure is a number, and it can be in any unit. I don't have all the units on hand, but it can be kilopascals, it can be atmospheres, millimeters of mercury, etc. The volume has to be in liters for this to work. The moles, obviously those are in moles. The constant, so for the constant, you don't have to know the constant. You can just type in a string. So if you want the atmosphere constant, if you want the torr constant, if you want the kilopascals, which is the joules constant, you can just put this in a string. You don't have to know what the number is. But this constant, this is a chemistry thing. It has to line up with the pressure unit. And then the temperature. This has to be in Kelvin, no Celsius. So one of the things to note, though, is that obviously in any of these problems, there's going to be a variable. You're not going to know what one of the values is. You're always going to know the constant. You're going to choose it, but you're not going to know what these other things are. So if you don't know what it is, then you put false instead of number. So let's say I don't know pressure, I would say ideal. Well, here I'll do an example down here. I don't know pressure. I'll put false there because I don't know what that is. It's going to help me solve that. For the next function is the Boyle function, and it's very similar. Except it's a little different because there's pressure 1, pressure 2. You just have to know which one you're putting in, and if you're doing a chemistry problem, you would already know. And again, liters only. Pressure can be in any unit. That's the word I'm looking for. But it doesn't. You can also put false in for any of these if you need to know. And then next one we have Charles. So this one's volume and temperature. Same thing applies here. Volumes in liters, temperatures in Kelvin. You can put false for any of these. Gay-Lussac, pressure in any unit you want, temperature in Kelvin only. Combined, we just have a lot more different things, but it's the same idea. Pressure, any unit you want, volume, liters, temperature, Kelvin. Same thing for the other side. False if you don't know what the value is. And then we have this one down here. So this function, it's not a gas law, but it's used within these functions. And it takes one parameter, the constant, a string. So in each of these functions, I'm just going to go through one to save time. And that will be the ideal one because this one's the most complex. But in this function, it's going to, first of all, set constant string equal to choose constant with parameter constant. So what this does is it gets the string you put in the ideal function, then it calls choose constant and puts that string as an argument. It sets up the constants right there, and it's going to choose the constant that is correct, the one you want, and it's going to return that. And obviously, that return will go into constant string. It's going to say variable equal to 0. We'll get to that later. Now it's going to do a ton of checks. It's going to say, okay, which one did the person say false for? Which one is the variable? What are we solving for? So in our test down here, we're solving for false. Oh, excuse me. We're solving for pressure because that's the first parameter, first argument. So we'll follow this for pressure. If pressure is equal to false, which is true, it is false, then it's going to set the variable equal to P, and pressure is equal to 1. And then we don't need to go through the rest of those, but let's say if it was temperature, it would skip through each one and go to the temperature if that was your variable. Then it's going to So the left side, so when I'm set this up, I thought of it as a literal equation, left side of the equal sign, right side of the equal sign. So left side is equal to pressure times volume, just like the PV equals nRT, PivNert, and right side is equal to moles times constant string times temp. And so here's where that one, the pressure equals 1 comes in. I'm going to set the pressure, so down here, this will be 1 times whatever the volume is. And that's just because you can't really just ask the computer to solve it, like solve for x. You have to kind of go through the steps. At least that's what I did here. So anything times 1 will equal 1. So that's why I did that. I mean, will equal the anything. So that's why I did that. Then I set final equal to 0. Now, here is where it gets into the solving. If the variable is equal to, so our variable is P for pressure. If the variable is equal to, okay, well, it's not any of those. That's if it's on the right side, so we can skip that one. But, if it's equal to P, then what it's going to do is set final equal to right side divided by left side. And this is, again, just a math thing. So you're just going to, because there's a variable on the left side, you're going to want to divide the right side by whatever's on the left side. And then it will set final to that, and it will return final. And console.log, it will give you the value. So we got this big number for the result. So yeah, that's kind of the gas laws library that I created. Apologies if it's a bit long, but I wanted to make sure I went through everything. So thank